Okay, while the slides are getting set up, we have Aditi now who will talk to us about how API dispatching is being used to improve performance in Python libraries.
So yeah, I'm just hello. Yeah, so I'm just going to start talking. So I'm going to just talk about dispatching approaches in different scientific Python projects. And so dispatching, you must have heard it like your package has been dispatched, your Amazon package, and it goes basically means it is going from location A to location B. And how does it go from location A to location B by some address information? So in programming also dispatching is kind of in a similar way, and but instead of going from location A to location B, it goes from library A to library B, the function call. And how it reaches the library B is via like maybe some information in the function call itself or the type of arguments that you are passing in. So like this. But why do we do it? So maybe to improve performance, like library B has better performance, and maybe it is like compatible with better types. And so now here's an example. So here's a library and it has basically a add function. So like calling a library another library would just mean like importing it and calling it. So I have like different if else conditions for library b1 b2 b, and you also have to like modify the function call for each of the library b1 b2 b3, and but this is not a very nice way to do it. So maybe we can generalize it a bit. Like you can see there are like these few steps that are getting repeated again and again. Like you get the library name and then you import it and then you convert the argument. Like maybe library b1 only takes z when it's float type, and then you find that add function inside library b1 and call it. So here like instead of like library A finding the function, I'm just saying give me a namespace of all the function that you support library b1 and I will just call the add function. And instead of library A converting the arguments, I'm saying you give me the convert argument function for all of your functions. And instead of importing, I'm using this import dunder method. And now a consequence is that like all the if else code blocks have become quite general, so I can just use a single if else. And here you can see like I've delegated these last two steps to library b1, and if library b1 does not want to do it, then of course like you would have to hard code it. But like maybe I can squeeze it a bit more by using a decorator. So I have just put this code into a decorator, and now you just have to put like a decorator on all the functions in library A to make them like dispatch to another library. So this is like basically dispatching, like you user calls the add function and dispatch will just dispatch to whatever implementation the user has wants to run. So now we are going to see example of networkx, numpy, and then like a little bit of scikit-image and spatch, how dispatching is implemented in those projects. So in networkx there are networks that we analyze. Networks are also called graphs and they have nodes, and if two nodes have some sort of relationship between them, we put an edge between them. So these are not like formal steps, these are just my observations that I have made in dispatching in scientific Python ecosystem. So this is a demo, you can like go and see it. So it basically like with normal NetworkX graph, it takes around 80 seconds, and with cuGraph, it's like 3 seconds, so it's quite fast. The between the centrality algorithm. These are like how we take the backend, like which backend to dispatch. So you can take this CU graph, which is like cuGraph object, and if you check the networkx underscore backend, it just contains a string called cusim. So we know that we have to, cugraphs, not cusim. We just know that we have to dispatch to the NX cugraph backend, or you can pass in directly as a backend keyword argument the backend name, or you can pass in as a global configuration, and backend priority is basically if cugraph does not work, go to graph plus backend, then parallel. And you can also set a environment variable, and you can see like two types of dispatching, like type based and name based. So type based means we are dispatching based on the type of the input argument, and name based is we are dispatching based on the name that you have given us. And entry points helps us to match, create a mapping between the name of the backend and the namespace of all the supported functions by that backend. So entry points are basically primarily used to like extend the functionality. So like the functionality of a vacuum cleaner is to clean, and you can just change the nozzle if you like want to clean the corners or something. But dispatching is like you can change the whole machinery inside the vacuum cleaner. Like we are allowing you to like change the whole implementation. So this is how entry points look inside networkx. We just have to like call this entry point function, and it groups all the packages which have this entry point with the group name networkx.backend. So like parallel cugraph, and so you can see this mapping between like the name of the backend, and this backend interface is nothing but a namespace of all the supported functions, and also like the convert functions, like function to convert a networkx graph to a NX parallel graph, and NX parallel graph to a networkx graph. So, and this is how it looks in the NX parallel side, like how you define an entry point to let the main networkx library that NX parallel is a backend. And these are some more features. So in NumPy, we don't do the conversion step because in arrays conversion is a bit complicated. So in arrays you would mostly see type based dispatching and not backend name based. So here we have like we call a function, we pass a CuPy array in a np.mean function, and what it does is that it takes that CuPy array and tries to find this array function method, and that this gender method automatically calls the CuPy implementation of the mean function. So but what is happening here, so it just basically takes the function name like np.mean and the type the CuPy array, and it can also be like some functions take like multiple arrays and all the other keyword arguments, and then we just see if it's a supported function and see if all the types are of the appropriate type, and if they are, then CuPy runs its own mean implementation. But one drawback is that there's no fallback in networkx. Fallback in the sense, if CuPy does not implement np.mean, then it will not fall back to native NumPy's implementation. But in networkx, it does fall back. Like if backend does not implement a function, it will go to the main library's implementation. And yeah, it evolved from array ufuncs, and in scikit-image, the challenge is that the main image object is a NumPy array. So ideally, you would think that we should adopt array API standards, like array API standards. Pradyut will talk about in next talk. Like this array function was not like suitable for all kinds of arrays out there. So array API standards was introduced, and also like scikit-image is Python heavy, so it's hard to adopt it. So we use entry points instead, and the goal is to like make it look like type based dispatching, but under the hood have entry point based. And currently we don't have any like it's a very basic implementation, and one possible solution is Spatch, which is short for Scientific Python Dispatch, that we are working on, which like potentially other scientific Python projects could also use to introduce this dispatching kind of mechanism. And this is a summary. Like in NetworkX, you either get an X parallel graph or a graph plus graph or an XQ graph, and then from the and then function checks the dispatchable decorator checks this NetworkX backend, and that's how we get the backend name, or we can get it from the user also, and then we load the entry point name and the backend namespace corresponding to that backend name, and from these two functions we get the output. And in NumPy we take the Dask array or a Coupa array, and then we run this array function, and that runs the Coupa implementation or a Dask array implementation. And next talk is this, and here are a few links if you want to read more, and I am around. So thank you.